Hi, my name is Matt Holliday and welcome back to my class on programming in Go. So for this next section, I'm going to delve into how Go supports HTTP networking. And we're going to do some very simple web servers and clients and a little bit more with JSON. So to begin with, I want to show this one slide because it summarizes some of the support that Go has. Okay, Go was designed fundamentally to build software in the cloud, particularly REST-based servers and similar things. Okay, so Go has all this stuff built into it. Essentially, it has a web server in the standard library, along with the parts that you need like cryptography and so on, to build a modern service in the back end. Well, we're going to start very simply, and so I'm going to move now onto my laptop in VSC. And what I have in front of me is the most basic server program in Go. So if we take a quick look at this, I'm importing net/HTTP from the standard library. Now this is different from the HTTP library we used to parse HTML before. This library has the stuff to make a server. And we really have two things here. We have the main function, and the main function's job is to start the server. So we bind a handler against a route. In this case, we're just going to have one handler that handles the top level route, /. And then we're going to start a server with a function called listen and serve. And the job of listen and serve is to open a listen socket, a TCP socket that can accept HTTP requests. And we're going to pass it the string 8080 after the colon. And that just says, pick the default IP address and start up on port 8080. Now what's going on above that is we have this func handler. And this is the most basic handling function. They're all going to have the same signature. So they take two things. They take a response writer, which is where all the output goes, and a request, which is the request that we got in from a client. Okay, so we get a client's request, we can look in and see what it is. It may have a body. Okay, when we start looking at more JSON stuff, we'll see, bodies with JSON and responses with JSON. And the job, of course, is to respond by writing stuff to the response writer that will be sent back to the client. Now, there's one thing that you don't see here, and that is this is a concurrent web server. Under the hood, the HTTP package will handle as many connections as your hardware will support. And so the handler is just handling one connection. It's got one client, one request, one response. We're done, but this could be running a lot of times. Okay, of course, right now, we're just going to run one at a time. So I'm just going to come down to the command line and start up my server, right? I put some executables in different directories to make this easy. And when I start it, it's not going to do anything, apparently. In other words, from the command line perspective, I started, it's sitting there. It didn't stop, it's just running. Now, what is it actually doing? Well, I have another window, and in that window, I should have started this with nothing. Well, we'll just take one of these out and show it, right? It's so fast you didn't see it, but actually up here in my address bar, I have localhost :8080/Matt, or I can go, Matt class or something. Whatever I put there after that / for the URL is just going to get echoed back to me. I mean, my web server is very, very simple. In the handler, what am I doing? Well, I have hello world from something. I'm just formatting a string. And what I'm doing is I'm taking the URL path, and it's after the first character. So I'm just knocking the / off and taking whatever that URL path is that was in the address bar of the web client, okay, Chrome, and printing it as a string. Now, where is it going? Well, it's going into W. All right, and W is this response writer. So the response writer is something I can write to. Now in the past, when we did things with fprintf, right, we gave it like os.standarderror. And that's a file, it's the file descriptor for standard error output. But in fact, what fprintf wants as its first parameter is something that can be written to. And the standard error output is just one of many things. So we have here a response writer, and a response writer is also a writer, of the kind that we can pass to fprintf or any of these other things that do output and send data into it. We can write data into it and not worry about the fact that, well, it's actually handling an HTTP response through a socket, yada, yada. We just write to it. So the string that we write comes out. There is one other thing that's sort of not quite shown here, and that is if we don't set any other status, then in fact, the status will be 200 OK. You know, that's not really visible. We could set another status, and we'll show how to do that in a minute. So that's my server. I showed it graphically by opening up Chrome, but I also have a client program we'll talk about in a second. And I can go run that client program and pass it, for example, my name, or just some argument, and it will also send it to that same web server, which is still running. If you look at the terminal on the left, lower left, that's running. I sent it, and it echoed back to me. I don't just have to use my client program. I could use curl, right? I could just type curl and my local host address and add something to the end of that URL, and here it comes. So again, I could write my own little Go client program. I can just run curl, or of course I could have used a web browser. They all do exactly the same thing. The server receives an HTTP request with a URL, cuts off part of the URL, and just echoes it back as the response. I'm pretty sure if I put a -i on that and I look at the response from curl, yes, I got a 200 OK. So by default, unless I do something else, I'm going to write to the response writer, and that's going to cause it 200 OK to come out. All right, so that was the server program. I'm going to leave it running for a moment, and I'm going to switch to the client program. Now, the client program that I wrote is only a teeny-weeny bit more complicated. Okay? My client program, I'm going to do this the easiest way possible. I'm going to use an HTTP library function called get, which doesn't give me a lot of control over the HTTP request. I can just give it a URL, and it's going to go and get some data. And so that's what we're doing. I'm giving it a URL, my localhost 8080 address, plus whatever was on the command line after the name of the program. So the first command line argument, I'm going to attach onto there. It's just a string, so I just do string concatenation, and I run get. And what get gives me back, it's going to give me a response, okay, and possibly an error. So we'll check the error. I didn't get an error. The very first thing I have to do, so the response can have a body, right? The server could send me back all sorts of things, a huge web page with pictures and text and so on, right? We need to close it, because if we don't close the body of the response, it won't close the socket, and we'll end up wasting a bunch of sockets, and eventually we'll run out. Okay, if we were actually running some sort of server program or any program that did a lot of requests. So it's up to us to close that, and we do it with a defer. This is the right place to do it. We opened a request and got a response. We check the error. The error is not, there's no error. So the very first thing is we do a response.body.close, and we defer it. Fine, so that'll take care of closing the socket. The next thing to do is we're going to look at the response status code, because we could have gotten a response with some other status code. We could have hit a page and said 404 not found, okay? In which case, you know, we'll want to deal with it. I'm not dealing with it here other than I'll ignore anything that's not a 200 OK, right? So now I use our friendly read all function, and this is a good place to use read all right? You know, read all from a file is questionable because the file can be large. It's unlikely I'm going to get a giant response from an HTTP request. So a lot of the times it's convenient just to do a read all. So I'll do a read all. That gives me some body. And of course, we'll check the error to make sure I could read it. And all I'm doing then is just printing that body. Now the body is a byte slice, right? If I go look at body, right, it's a slice of bytes. It's bytes coming off the network. And because we know it's a string and it's printable, we're going to convert it to a string and print it. All right? And so that's the client program we wrote. Again, all it's really doing is doing an HTTP GET, and you know, there's a bunch of error checking, closing the body, checking the status, and getting the result out of the body, which in this case is just a string. Now, I want to switch back to the slides just for a moment, because I want to bring something out here about the nature of the handler. Okay, very shortly, we're going to start talking about object-oriented programming in Go. And when we'll start talking about things like interfaces and methods. And the HTTP service in Go, its standard library stuff, is based on object-oriented programming. So one of the things we have in there is we have an interface. And the interface is the handler interface. And the handler interface has one method, which is the serve HTTP method. And not surprisingly, it takes a response writer and a request as parameters. Okay, so we're looking for things that will implement that. We created a function called handler. Now that function called handler is a member of the handler func type, because I have type handler func here, right? And its type is a function that has those same two parameters. So it matches, or it's going to match structurally, the function that I had, right? And now what I've got is a method. Now we haven't talked about methods yet and how do you declare a method, but this is a method declaration that runs on a handler func and does the serve HTTP method by actually calling the function. Okay, so I want to unpack one thing here real quick. And again, we're going to dive into this in just not too far down the road. Go doesn't have classes, but Go allows methods to be put on any user declared type. So I can create a method for a function, and the method runs on the function, in this case, just by calling the function. Which means I can take a function that I wrote in the code, the handler function, right down here. I can take that function and use it as an object that satisfies the server interface, the handler interface, with a serve HTTP method, so that the web stuff in Go can just use that handler. And I'm not going to dwell on this right now. This is a kind of a preview of where we're going to go into Go's object-oriented programming, because it's a little different. Okay? You are probably not going to have been exposed before to the idea of putting methods on things other than classes. And classes are actually pretty restrictive, because a class is just essentially a struct with methods, and here we have the notion of I can put a method on a function. Why not? It's just an object. So now I want to go back to my client, and we're going to make some changes to it on the fly here. Right? I'm going to have my client use some stuff with JSON, and I'm going to stop working with my local server for the moment. So I'm just going to kill it off with a Control-C. Right? And I want to take my client, let's see, I'm good as I go as far as that. We're going to create a constant for a URL. And I'm going to use a service that's out there on the web that's actually very neat. All right, and assuming I've typed that correctly, okay, JSONplaceholder.typicode.com is a server that's going to return to us some JSON, okay, in response to certain requests. That allows us to actually just write some code and see what happens when we go and get JSON from a server and bring it back. Okay, now, you know, it does that by getting, it has these fake to-dos, and the to-dos are numbered. So we're just going to take this base URL and add on to it to-dos/1, so we get the first to-do, right? And the rest of this stuff is fine. All right. Now, for the moment, all I'm going to do is just run this and get the JSON string printed out. So I'm going to start a new terminal just so I have a bit more room to type stuff. And we're going to just go and run this program. And it's going to dump out some JSON in a string. Let me move this up a little bit. Right? And if we look at this, all it really did was go out to this website, get the JSON and print it as a string. We're going to do more than that here in a sec. Okay? And so this is what comes back. Like we get a user ID, an ID, a title, completed, true or false. The user ID is kind of bogus, but the rest of this is interesting. And what I want to do now is I want to add into my program the stuff necessary to actually bring this into a Go type. Right? So we're immediately going to add onto here the JSON package. Okay, and now we're going to create a type. Okay, so I need a struct to hold the to-do that's coming back. And I'm going to put some fields in here. Now, the fields have to have an uppercase letter or JSON won't decode them. The structure doesn't. I don't have to export the structure if I don't want to. I just have to export the fields. So to-do here with lowercase is fine. Besides which, I'm not writing a library right now. It's just a main program. Okay, so I'm going to put in here three things. The first is the ID. The second is the title. And the third one is going to be whether it was completed. And again, I'm putting in some JSON tags because this is going to come back to me in lowercase, but the name of my fields have to be in uppercase for them to be decoded. All right, and when I do a save, right, now, so I have my VSC set up with some additional tools. When I did save, it immediately formatted my code, and I also have some linting already set up, and so it comes right back and tells me, oh, by the way, you're not using to-do yet, but we will. All right. So I need to come down here and I need to do something slightly different. And that is, I'm not going to print this. Instead, I need to create a space to decode into. And now we're going to unmarshal the body that we got. Okay, so we did a read all. The read all gave us a body, which is a byte slice. We're going to decode that byte slice into item, right? Add some error handling. And print the item. Okay? So now when we do this, instead of seeing some raw JSON text, I should see go printing out to me the value of my internal object, this struct of type to-do. And as soon as I run this again, hopefully it'll update the linting information. And so I actually save it. Okay, I saved it. And now I should be able to run it. And there we go. So if I look down at the bottom down here, what I've got is I've got the, the output from %v, right? It's a main.todo structure with these fields. Now, if you go back and look at my to-do, right? My to-do only has 3 fields. I got 4 back from this typicode.com website. I got a user ID. But here's a big trick. I don't have to put in my internal Go structure any fields I don't want. Okay? So I didn't put the user ID in my to-do struct, and it will not be decoded. It will be ignored. Okay? Which is just fine. All right. Now, if you really don't want to ignore fields and you're worried about that, there's actually an option. There's an optional way to set things up so that when you decode and there's a field that doesn't decode into your struct, you get some sort of warning or error. But at the moment, and this is personally how I do JSON, I'm perfectly happy ignoring parts of the JSON I don't want. So I'm only going to put in my struct the fields that I want to decode from this JSON coming back, which are the ID, the title, and whether or not it's completed. Okay, so I'll take those 3 and put them in my struct. And now I could do whatever, right? And I could run through this and get other ones and summarize them or whatever. Like go through and find all the ones from 1 to 100 and see if they're completed or not, right? And just print out the ones that are not completed. I could do that because now I've got a Go object, right? A struct of type to do with the data from that JSON. Now I can use Go logic on it. I'm going to go down this road a little bit further. Okay, I'm going to modify my server so that when I send something to my server goes to typicode and gets the data for the to-do and puts it into some sort of formatting. Now in this particular case, we're going to then be focused on using Chrome because what we're going to do is cause the server to generate some formatted HTTP output, and that'll show up in our browser with some formatting. It won't just look like a raw string, it'll actually look like something a little more. So to do that, we need to actually take a bunch of the code from the client here and move it into the server. So our server will be both a server and a client. It will serve our local request by making a client request to the Typicode server, getting a response, and then reformatting that response and providing it to us. So I need most of what's in the client right now to go over to my server, right? So I need a couple of these guys that I didn't have, all right? And I'll need the rest of this. Now my main function won't change, but my handler certainly will, because my handler will now have to turn around and do the client logic. So I'm actually just going to cut out a whole bunch of this and make a small modification to it. Yeah, I want that much of it. All right, so I'm going to get rid of this and put in this. Now, I started doing that, and what I'm going to do is switch over to another copy I've already been typing in, so that a little more of this is put together, because I want to go through a couple things, and it's going to be tedious if I type them all out. All right. The first one is I've got a form. So one of the packages in Go is a templating package. There's actually two versions. A plain text templating package, which would probably be great if you were going to do generate emails, right? You know, fill out a form in an email and generate emails. And then there's one for HTML. And that's the one you want to use when you're doing a lot of this web stuff, because it's designed to prevent certain kinds of security problems with HTML injection, right? So we'll see up here, I added one more thing up here. I have the HTML/template include, right? And that's going to run on a form. And I didn't want to type the form in from scratch. It's a little tedious and I might make a mistake. But our form is basically HTML with some stuff in it. And the stuff is wherever I have these double brackets like this, right? It's going to take data that I give the form and put that data into the form and render it, okay? And this is, if you've worked in any kind of web service stuff, you've seen this sort of thing in other languages. This is just the Go way to do it. So I have a header, it'll take a to-do, it'll put a pound sign and then a number that's going to come from some ID field, right? And then it's going to have a div with and a printf. So in these double things, it's not just data, there's certain directives I can put in there, and I'm literally going to tell my form to do a printf of the user ID with this format, user and %d for the number. Okay, except I didn't have a user ID, so I'm going to have to go and put that back in. And then I have a printf with a string and in parentheses completed true or false, and those are going to come out of the title and completed fields. All right, so I better come back up here and make sure I have a user ID field, because for this particular example I have it there, right? And my handler function, it starts off just like the client. I have my base URL, except what I'm going to do now is I'm going to go to the incoming request, pull the path off, and attach that to this base URL and send it to Typicode. So if I go to my web browser and hit my localhost 8080 and type todos/1, it's going to take the todos/1, send it to Typicode, get the data, right? And there's a little more going on here, because now I've got a web server that's acting as a client. Well, let's suppose I can't talk to Typicode. It doesn't work. What do? So my handler can do things with the response writer, and one of the things I can do is I can signal an error. And there's actually a method that makes that real easy. It's the http.error method. It takes W, the response writer, it takes the string from my error, and it takes a status code. And in this case, if I can't get to Typicode, I'm going to say status service unavailable. That's just a choice. All right. Otherwise, and here's the other trick. If I do that, I must return. Okay. Once I get this handler, if the handler says there's a problem, I'm going to register the error. I'm going to respond with the error on the writer, and then I need to return, because otherwise I'll keep running this logic in my handler that's bogus because I never got a response from typicode in the first place. Okay, so remember, if you do one of these http.error things, return. Okay, I didn't get an error, so I'm going to close the body, right? Otherwise my server is going to run out of sockets, and that will happen for real now, because now I've got a server also acting as a client. Okay, we'll do the read all we did before. If that doesn't work, we'll signal an error and again return, and then we'll unmarshal and so on. Now there's a little more going on here. I got the item by unmarshaling the JSON, so it's in our internal Go struct, and I need to do something with it. So I'm going to go and create a template, okay, and I'm just going to give it a name mine. That doesn't really matter right now. You can have multiple templates in your program and give them names. I'm just going to create a template, and I'm going to parse it, and what I'm going to do is I'm going to tell it to parse this form text up here. All right. And once I've done that, then I'm going to tell it to execute, and I'm going to execute by passing in my item. So the item that I decoded from typicode into my Go struct is going to be the source for these fields in the form like .id. And of course, where do they come from? They're the actual fields from the to-do struct. Now, this is going to be another case of reflection. Under the hood, the whole template mechanism is going to do reflection to look at my form and to look at the to-do structure and figure out how to get the right fields from the right places. Okay, just magic. So now if I run this, okay, I need to make sure, I don't think I have anything else running. I think I killed the server before. So I'm going to go up to that, and I'm going to start this server, which is a server and a client. So I'm just going to run it. And I'm going to go over to my web browser. Now before, you know, I was typing something like mat/class, and it was just returning text to me. But now I'm going to say todo/2, and it comes back and puts into my web browser formatted text. So I've got a header number 1, right? And my header number 1 is todo with a £sign and a number. And then it says user 1, here's some text, and in parentheses, completed, true or false. This is exactly what my form said to make. Okay, if I go back and look at my form, right, and the form is rendering the data out of the item that I decoded from the JSON that I got back from typicode. All right? Okay, so before I'm done with this segment, I want to go back and change one thing, right? I have some stuff in here I don't need. In particular, IOUtil. All right, and up until now, we've just been treating IOUtil and doing a read all and so on, getting all the bytes, right? But here's the thing, right? My JSON unmarshal, there is an unmarshal function that will take a slice of bytes. And I did a bunch of extra work to get those bytes, which I don't need to do. Because in reality, my response.body is something I can read from. So I'm going to change this a little bit. Right? I still need my to-do item, but I want to change this by creating a decoder. And let's see if I've remembered correctly. Yep. Okay, so instead of, and now I can also, I could have done this before. I can just fold that into there. Right? So what I've done here is instead of going to my body, doing a read all to get the bytes into a byte slice, and then taking that byte slice and passing it to JSON.unmarshal, which is sort of like a global function, I'm going to do something different. I'm going to create a JSON decoder and give it the response body, because the response body is something a decoder can read from. And now I can just turn around and say, hey, and then go and decode into the item. And I didn't have to call read all and worry about an extra error. It's all going to be taken care of right here. So I should be able to save this. All right, I'm going to kill the old one and start it up again. Okay. Yeah, I forgot to call new decoder, right? Decoder is the type, new decoder is the function that gives me one, right? I call new decoder with the response body, and then I can call decode on the decoder, okay? Makes a lot more sense. So let's try that. Let me save that. And voila, it starts up. And now I can go back over here and do the same thing, but I'll just change the number and we'll try getting number 3. And here comes number 3. And I can go on and get number 4. One of these will probably be completed. There we go. I got number 4. Number 4 is completed. Okay, so it's exactly the same functionality, only I simplified this. And the way I could simplify it is response.body is a type of read closer. And a read closer is an interface with methods, but the response.body is one of the things that can satisfy it. And so I can pass it into a new decoder, and it will just read from the body of the HTTP response directly. Okay, before I was copying it with IOUtil and then passing it as a byte slice. Now I'm just saying, hey, make the decoder from the response body and then use that to decode. And that saved me some steps, right? And that's the beginning of where I'm going to start talking about some of the object-oriented features in Go. Because what does new decoder take? Well, new decoder, if we look at the Go doc, its parameter is an IO.reader. Okay? Its IO.reader is an interface. It describes the functionality desired of some type of object, where that object provides a read method so that bytes can be read from it. And there's all sorts of things that can be used to create a reader. I can have a reader from a file, I can have a reader from the socket, or I can create a byte buffer, and the byte buffer object can be treated as a reader. And so I can I can pass all sorts of parameters into new decoder that will satisfy the IO.reader interface. And the decoder will be able to decode by reading the bytes directly from that reader. All right? And of course, the response.body is a reader, among other things. Okay, so that's the basics of doing HTTP with Go. All right, I created a simple server that just created a very simple response, and then I demonstrated a client that essentially did a simplified version of what curl does. And then I created a slightly more complicated server that could actually go out and do a client request against another server, right? So I go to one server, it does a REST operation to a second server, gets some data, and then formatted it and put it in a web browser for me. And along the way, I've started a little bit into the discussion of what is object-oriented programming in Go. So we talked just a little bit about interfaces and methods, and very soon we're going to get into that. It's a topic of its own and worthwhile.